He asks, does your birthplace have meaning in your survival and longevity? Can being uprooted at a vulnerable age increase your life history? Well, presumably yes, if you're born in a very dreadful place, into a very dreadful environment, and stay there, it's going to have an impact on your life history if it's very stressful or polluted. As for a being uprooted at a vulnerable age, can it increase your life history? I would assume so. Yes, because it would teach you that life was unstable. I would have thought that moving house a lot as a child is going to teach you that life's this unstable thing and you can't really predict things or settle. So it would kind of get you used to being a nomadic vagrant.
I don't know if the actual act of, say, moving around or growing up in an unstable environment is going to necessarily induce in you faster life history. What it might do is reinforce an underlying genetic predisposition towards faster life history, as manifest in the fact that it's clearly going to be the parents who are going to be creating that instability, that unpredictability in the environment. So, therefore, the instability of the environment is going to be a product of a gene-environment covariance. That environment's going to be part of the extended phenotype of fast life history parents. So, what you have is children who are already predisposed towards being fast life history by virtue of having a genetic disposition towards growing up in an environment that's been created by fast life history parents, which is actually a product of their extended phenotype. So, there's a basic confounding there. So, to properly test this, you would have to control for parental characteristics. So, holding constant the level of the trait in the parents, is there still an additive effect of the environment net of parental genetics on offspring life history characteristics? Now my suspicion is yes, there would be, because we actually have similar naturalistic and quasi-naturalistic experiments in the form of age at Menich in young girls, so the age at which they go through puberty. We know that pubertal age has been decreasing over the years. There's some evidence it's actually under selection. But there is also some evidence to suggest that it's not just a function of the parents of the child having gone through puberty at an earlier age. You can control for that, and you can actually see that there is factors in the environment of the young girl that also have an additional effect on the age at which they go through puberty. Jay Belsky did a lot of research on this, and Bruce Ellis.
Is there any kind of consensus on why the pubertal age is declining so much?
Well, it seems to be a mixture of two things. I've seen at least one paper that tried to look at polygenic scores. So it tried to do polygenic scoring on age at menarche, and it found indications that people who go through menarche earlier in life tend to have larger numbers of children, which kind of goes against the idea that there's a general selection for slow life history. So it seems like things are actually quite a bit more complex, and maybe there are some psycho-behavioral life history traits that are under selection.
Couldn't it be that the manifold between the different components of K is breaking down?
Yes, that's what we found. Because what we did to test this was, we actually broke apart the K factor in the US population into its different bits. And each of these bits are analogous to subtests on IQ tests. You can get a loading similar to the G loading, which is how well each of those bits independently measures G. And some subtests are better measures of G than others. In the same way, some life history components are actually better measures of K than others. So, what we were able to do is work out the strength of selection for each of the bits independently, and then correlate that with the level of K saturation of the bits. And we found they were unrelated to each other. Moreover, we then computed the heritability of the bits and correlated that with the strength of selection. We found that was positively correlated, although it wasn't a huge positive correlation. So it seems like the K saturation does not moderate the strength of selection, which suggests that life history is being selected for in an idiosyncratic basis. It's being broken apart. But the heritability of the components is high because of the strength of selection, as you would expect from the breeder's equation. When the heritability is high, we'd expect selection pressures to be higher as well, simply because the two are proportional to one another.